Okay children, once again the online tutor. So this is my fourth tutorial of the straight line lesson. So the last tutorial I have given you two homeworks question, right? So it is given that ABCD is a parallelogram. ABC coordinates are the vertices of a parallelogram, right? So the coordinates are given. Find the coordinates of the point D. Find the equation of the diagonals, right? So how to do this? First of all, you just need to draw a diagram. With ABCD. ABCD, right? The A coordinate is 4, 2, 1 minus 2, minus 3 plus 1. This is my D. Right. We just need to find the D coordinate. So you know, in parallelogram these two sides are equal, right? So the midpoint, we can find the midpoint M, right? M will be 4 minus 3 divided by 2, 2 plus 1 divided by 2. So it's half and 3 by 2, right? Then I assume D as x bar and y bar, and again x bar plus 1 divided by 2 equal to the m coordinates. The m coordinate is half, then x bar is minus 1. What about y bar? Y bar minus 2 divided by 2, it's equal to 3 by 2. Then y bar will be 5, right? So this is the coordinates of the point D. Plus 1 and plus 5. Then we need to find the equations of the diagonal, right? So how to find the equations, right? First of all, finish this. Equation of AC. So first of all, I just need to find the MAC, right? MAC one over 7, and equation of y minus y coordinates, you can select any coordinate. I select a coordinate, right? X minus x coordinate is 4. 7y minus 14, x minus 4. This is the equation of AC line, right? And after, same thing for the other diagonal BD. First find MBD. Y coordinate difference 5 minus minus 2, x coordinate difference, it's become 0, right? So infinity, tan theta infinity, theta become 90, right? Theta become 90. So what that meaning? So that meaning is our straight line, right? So the BD straight line is perpendicular to, right? BD straight line perpendicular to the x-axis, perpendicular to the x-axis, right? Then the equation will be x equal, we just need to find the x value. So the x value is 1, right? So here the x value is 1. X equal 1. This is the equation of the line. The equations of the diagonals are x equal 1 and the other one, right? So the previous one. Okay children, let's move to the theorem number 11, right? Perpendicular distance between two parallel straight lines. Perpendicular distance between two parallel straight lines, right? Okay. These are my straight lines. Ax plus by plus c equals 0, right? Lx plus my plus n. Sorry. If it is parallel, then it should be again ax plus by plus e or something, right? So the perpendicular distance, right? This is the distance d should be equal to c minus e over the square values of the coefficients a square plus b square. So this is the perpendicular distance between two parallel straight lines. Okay, this is my example 3x plus 4y minus 12, right? So I have to find the distance d, which is 18 minus 12 divided by the coefficient squares. So 18 plus 12 means 30. 30 divided by 9 plus 16 is 25, it's 5. Then 6 units. 6 units, right? Right. So the next important thing is how to prove that theory. So let's move to the proof, right? Okay children, so can you remember last day I told you this is the distance between the point to a perpendicular distance from a point to a straight line, right? So using that, so I am going to prove the equation of the parallel equations, right? The distance between perpendicular distance between two parallel lines, right? So what I am going to do, I am just assume that point x naught y naught, right? And we can find that d, right? So d will be ax naught plus by naught plus e divided by a square plus b square, right? And you know this x naught and y naught is satisfied by ax plus by plus c. X naught y naught, right? Therefore ax naught by naught plus c becomes 0. Ax naught by naught equal minus c, right? Now I am going to substitute this value to the formula. Then it's e minus c over a square plus b square, right? So this is the perpendicular distance between two parallel lines, right? So this is the proof. So if it can be c minus e or else e minus c, right? So it can be changed because of the modular sign. Okay children, next move to the equation of the bisector of the angles between two intersecting straight lines. So in this theory, I am going to construct two straight lines, right, which are intersected each other. The equations of these ax plus by plus c equals 0, lx plus my plus n equals 0, right? So actually if two straight lines are intersected mean we will have two bisectors, right? The one is acute bisector, other one is obtuse bisector. Acute bisector, obtuse bisector, right? So what is the so actually then we will have two kind of equations, right? The acute bisector equation as well as the obtuse bisector equations, right? So then how to find it? It's mean ax plus by plus c over a square plus b squared equal plus or minus lx plus my plus n over l squared plus m squared, right? So here you have plus or minus. The plus or minus mean if you substitute plus you will get one equations. If you put minus, then again you will have another equation. So both the equations mean acute and the obtuse, right? But we don't have in this using that theory we can't specifically tell this is the acute bisector or this is the obtuse bisector, right? We have another method for to choose the acute and the obtuse bisectors of these bisectors, right? Okay, so let's move to a counter example. Okay, children, we'll see how to find the bisectors equations, right? So here I'm going to substitute the values to the equations, right? 3x plus 4y minus 2 divided by 3 squared 4 squared, right? And 5x plus 12y minus 6 divided by 5 squared 12 squared. So here it's 3x plus 4y minus 2 divided by 5 plus or minus 5x plus 12y minus 6 divided by 13, right? Then the next step is you have to simplify it further, right? So I'm just putting plus sign. Then it's 13 into 3x plus 4y minus 2, 5 into 12y minus 6, 39 next, 52y, 26, 25x minus 30, 14 next, 8y plus 4 equals 0. So this is a bisector, right? And also the negative one, 13, 3x plus 4y minus 2 minus 5, 5x plus 12y minus 6, 39 next, 52y minus 26 minus 25x minus 60y plus 30. Then it will be 64x (12y) and 20, 56, right? So these are the equations of bisectors. Equations of bisectors. So we can't tell specifically what is the acute, what is the obtuse, right? But we can find the equations, right? Okay, children, let's move to another example. Let L1 and L2 be the straight lines given by 3x minus 4y equal to 2, 4x minus 3y equal to 1. Write down the equations of the bisectors of the angle between L1 and L2, right? So L1 and L2 was given. L1 and L2 are 3x 4y minus 2 equals 0. 4x minus 3y minus 1 equals 0, right? So how to find the bisectors? If you choose positive, if you choose negative, seven x, 7y minus 3 equals 0. So these are the equations of the bisectors, right? So this is the answer of the first Rome number. Okay children, so the next Rome number, we just need to verify what is the acute bisector, right? So the steps is, first of all, you just need to select one straight line, right? First select this, right? And the gradient is, then the gradient will be 3/4, right? And the second, right, you can choose anything. You can choose both of one, right? So here I'm select minus 1, right? Then I assume this is L1, L2, L3, L4. Now check the angle L1 and L3. This is my 3/4. This is my 1 plus 1, 1 plus 3/4 minus 1. Alright. So then, so the answer will be 7/4 divided by minus 1/4, right? So the tan theta become 7, right? 7 means theta greater than 45 degrees now. So the tan theta 1 equals 45. Tan theta 7 mean, so what is the angle? So it's more than 45. So the more than 45 means never be the acute bisector. So surely it's obtuse bisector, right? Therefore, your select one is wrong, right? Therefore 7x minus 7y minus 3 equals 0 is the acute bisector. So this is the mechanism of finding bisector, acute bisector. Okay, this is my next example, right? First you have to find the acute bisector. Sorry, first you have to find the bisector's equations, and the second one you have to select the acute bisector, right? So what is the mechanism? So first I am writing my equation. If it is plus, then plus 2x, then it's minus 2x. Minus 4y. Come to the other side, then plus 4y. Plus 8, come to the other side, minus 8. What about minus 1? 6x plus 2y plus 4y minus 6y plus minus 8, come to the other side, minus 1. These are the equations of the bisectors, right? So the next step is selecting an acute bisector. So I am just selecting this one. The gradient is plus 2 and this gradient m equal 1. Right, then tan theta m1 minus m2 2 minus 1 over 1 2 into 1. Right? Therefore 6x minus 6y equals 0 is the acute bisector. Is the acute bisector, right? Is the acute bisector. So I put some homeworks to be done, right? You can try it. Right, these two you can try it. Okay children, let's move to an example. Another example. The equation of the diagonal AC of a rhombus ABCD is 4x 3x minus y equal 3 and B is 3 1. Also the equation of CD is x plus ky equal 4, where k is a real constant. Find the values of k and the equation of BC. Right. So first of all, you have to draw the diagram. This is my diagonal. This is my rhombus, right? B, C, D. So the details, equation of diagonal AC. Where k is a real constant. Find the value of k and the equation of BC. Equation of BC, value of k. Equation of BC, right? Okay, so the first thing, the value of k, right? So we just need to value of k. So how to find that, right? So you know this BD and AC are perpendicular to each other because of the rhombus, right? So this gradient, which is 3, right? This is M2 M1. Then M1 into M2 will be minus 1. M2 is minus 1 over 3. Then equation of DD, y minus 1 equal minus 1 over 3, x minus x coordinate is 3. 3y minus 3 minus x plus 3. 3y plus x minus 6 equals 6. Right, so this is my M, right? Equation number 2, and the other 3x minus pi equation number 1. So solve to find m. Solve to find m. X is 3 by 2, right? X is 3 by 2. So what is y? Y also 3 by 2, right? Then after, what I am going to do, I am just going to find the coordinates of D, right? The next is finding the D coordinate. Then I am going to find D. So D as x1 and y1. x1 plus 3 divided by 2 equal 3 by 2, because these all will be equal now. x1 becomes 0. K equals 2. The K equal 2. Then after, we just need to find the equation of BC, right? How to find BC? I'm going to find C coordinate, right? I assume it's x2 y 2. This is my diagonal, 3x minus y. Number 7. This is my C coordinate, right? Next thing is to find the gradient of BC. 2 by 7. This is the equation of BC, right? So this is the step. So what I did first, I found the M coordinate, right? And I using the M coordinate, I found the D coordinates and I substituted the CD equations to find K. And after that, I simultaneously solve the AC line and CD line to find the C coordinates, right? And after that, I found the gradient of BC. Right, the gradient BC, using that gradient value I just write the equation of BC, right? Y minus y naught equal gradient into x minus x coordinate method. Alright, so this is the way of find that lines and all. Okay. This question is selected from 2016 LA paper, right? Okay children, let's move to the next theorem. The condition that the two given points are on the same or opposite side of a given straight line, right? Right. Opposite side. This is my straight line. P1 x1 y1 x2 y2, right? So opposite side means x1 y1 x2 y2, right? So what you just need to, you just substitute the points to the line. Right, I'm just substitute the coordinates to the straight lines and it should be greater than 0. Right, so this is the first condition to be satisfied. Same if it is in same side, so the product of the values, right? So if you substitute the values to the coordinates, right, and the value should be greater than 0. If it is in the opposite direction, right, opposite directions, the value should be less than 0. Value should be less than 0. Okay, this is my example, right? So what I am just doing, I am substituting my therefore P1 P2 are in opposite side, are in opposite side.